we look at section 4.2, implicit differentiation. To lead into this method that we'll be using on these implicit equations is just applying chain rule when necessary. So we have 4 examples that I want you to write into your notes, and let's write down how to take the derivatives of these 4. I'll give you a second to write them down. Okay, someone tell me how to take the derivative of the first one? F prime of g of x times g prime of x. Good. Next one? Fred, try that one. That one you asked me about. 2 times f of x, we leave that alone, to the first times good, f prime of x. Perfect. All right, how about this third one? Same idea. Please note that that's not y times x, that's y of x. So Bridget, can you help me with that one? Y of x. Yep. Times y prime of x. Yep. Good. And then finally this last one. This one, is this an implicit or an explicit expression? Implicit, it's got both. Bradley, help me take the derivative of that one, please.
Wouldn't it just be 1 plus y?
Derivative of y.
So 1. Oh, wait, no.
1 plus, how can we write derivative of y? Y prime or dy dx? Yep. All right, so this one is an explicit expression. This leads us into where we are going right now. So number 4 represents an implicit expression. We call it implicit because it is not explicitly solved for y in terms of x, or x in terms of y. All right, so the next thing I have for you, each time we learn these derivative rules, I keep telling you the things I want to be going through your head. So here is what I would like to see you thinking about when we do implicit differentiation. The basic rule for implicit differentiation is that anytime you take the derivative with respect to x involving y, you follow with a dy dx. This is done because we are applying chain rule. So, for example, if we wanted to take the derivative of y squared, I want you to think of this like chain rule. We have some function y, that's the inside, and that is being squared. Squared is the outside function. So how do we apply chain rule if something squared is the outside function? 2 times that something, which is y, times the derivative of the inside. Well, the inside is y, so the derivative would be dy dx. So that is the chain rule. And you will apply that in implicit equations anytime you're taking the derivative of the y. Okay? All right, and then when we get into this, students often ask, when we take the derivative with respect to x of a term such as x squared, the derivative is 2x. Why are we not writing dy dx or dx dx after that? Well, what is dx dx? Just 1. So really, you could write it every time if you wanted to, but we're just multiplying by 1, so there's no need. Okay? So now, let's go take a look at that problem that was the implicit equation on the first slide. So your book presents a nice little process, and this is the same in I've never seen anyone teach it any differently, with implicit differentiation. The first thing you do is differentiate both sides with respect to x. You get your dy dx's on one side and your values without dy dx on the other. Factor out the dy dx and then solve. So let me give you a second to write that down, or shorthand for yourself, whatever you want to do, and then we'll do this example together. We'll go ahead and try this example. Let me move down a little bit. Okay, we need to take the derivative of both sides of the equation. So the derivative of x cubed is 3x squared plus 3y squared followed by dy dx. Now, some people like to write y prime instead of dy dx. I prefer you do dy dx because students often mix up their y's with their y prime. They look too similar. Just little errors that get made all the time. So, now, the next thing I have to warn you about is 9xy is a product. So we need product rule. And there's a subtraction in front, so always put bracketing off of your product rule so you remember to distribute that negative. And we'll call 9x our first term and y our second term. First times derivative of the second would be 9x times what? Derivative of y. 1 dy dx. Right? The derivative of y is 1 dy dx. Plus the second, which is y. Do I need to write dy dx? No, I didn't take the derivative. Times the derivative of the first, which would be 9. Equals what? 0. One of the most common errors, if this is any constant, the derivative of that is going to be 0. Students forget, they either forget to take the derivative of that, or they take it and they think it's 1 or something like that. So remember, derivatives of constants are 0. All right, so now we need to rearrange things, and we need to get dy dx's on one side and numbers on the other. Yes?
Can you explain why you multiply by dy dx after the 3y?
I can. So remember, we talked about if I had to take the derivative of y squared using chain rule, the inside function is y, the outside function is something squared. So we take the derivative of the outside leaving the inside alone, that's 2y, times the derivative of the inside. Well, the derivative of y is dy dx. So that means every time I take the derivative of a y, I have to follow with that chain rule dy dx. Okay? So let's clean this up a little bit. We've got 3x squared plus 3y squared dy dx. Minus 9x dy dx. Then what? Thank you. Minus 9y equals 0. Let's get our dy dx's on the left and our other values on the right. So I'll subtract the 3x squared. So I'm moving anything that is not attached to a dy dx, and I'll add the 9y to both sides of the equation. And I now have 3y squared dy dx minus 9x dy dx equals negative 3x squared plus 9y. All right, so we've differentiated both sides. We've collected our dy dx's on one side of the equation. Next, we will factor out dy dx
that first step, you didn't have to put the differentiate 9x, did you? You could have put the 9 out.
You could have, yes. Yes, it could have been minus 9 times the product rule, yes, that would be fine. So here we would have 3y squared minus 9x times dy dx and equals negative 3x squared plus 9y. Almost there. What's our final step in our process? Solve for dy dx. So we will divide by this entire factor. And there is our derivative. dy dx equals negative 3x squared plus 9y over 3y squared minus 9x. I have a question. What would have happened if we chose to move our dy dx to the right and keep our numbers and values without dy dx on the left? No, no.
You would have just gotten negative dy dx.
We would have gotten, in the final, when we solved for this, we may have gotten 3x squared minus 9y over negative 3y squared plus 9x. Doesn't matter which side you do, the negatives will cancel out to the same overall expression. So it doesn't matter if you move dy dx to the left or to the right, as long as your algebra is sound. Either way is fine. Okay? So now, I could ask you a question like, write the equation of a tangent line at the point 2, 4. We know how to do y minus y1 equals m times x minus x1. To get your m, you will be plugging in an x and a y into this derivative function to come up with a number. That's fine. It's absolutely okay that our derivative is defined using x's and y's. Okay? So that's what we're going to do next, and you're going to do it at your desk. Get a little practice here. So we have this one. So a classic example of implicit equations would be conic sections, right? Circles, ellipses, hyperbolas. They're all in the form of x minus h squared over a squared plus y minus k squared over b squared equals 1. So they're always mixed like that. Well, here is an equation of an ellipse, and I want you to come up with the tangent line and the normal line at the point negative 1, 2. Give it a try. Okay. So when we start this, we end up with 2x minus the product rule, so my bracket is there. First times derivative of the second. That might be the problem or not. Do you have that? Plus the second times the derivative of the first. Did you have that x? Take a look. Right. This should be first times derivative of the second, so that x should stay.
Oh,
Okay? All right. Let's see. Plus 2y dy dx equals 0. Let me distribute my negative. 2x minus x dy dx minus y plus 2y dy dx equals 0. Now we're going to separate things, so I'm going to move the 2x and the y to the other side. And now I have, I'll write it in this order just so it's nicer to see, 2y dy dx minus x dy dx equals negative 2x plus y. What's next? Factored out, dy dx out in front. 2y minus x equals negative 2x plus y. Divide by the 2y minus x. All right. And now for the tangent line, I'm going to have y minus what value? 2 equals my m, I'll find in a second, x then what? Plus 1. I need my m when x equals negative 1 and y equals 2. So I'm going to get negative 2 times negative 1 plus 2 over 2 times 2 minus negative 1. Giving me what on top and what on bottom? 4 over 5. That's my slope for my tangent line. Remember, when you put in slope, you are not putting in a function with x, you are putting in a number. So here is my tangent line, and then a quick change makes it my normal line. Y minus 2 equals negative 5/4. X plus 1, and there's my normal line. Questions on that? Okay. I will bring up your homework, which I think is 1 through 31 odd, on page 167. Oh yeah, good, it's up. It's up already. Good. 167, 1 through 31 odd. And please note, we're doing 2 days on implicit differentiation. We'll have nothing new in class on Friday. We have more work time on it. Okay? Important. Okay?